Hello, this is question 6 on your June 2021 paper in Mechanics 3. It's an elastic springs and strings question, and I'm going to show you how you can get full marks. So you have a particle P, mass 0.4 kilograms, is attached to one end of a light elastic string. Natural length is 0.8, so I'm going to start to write those things. Length is 0.8, that's L. Modulus of elasticity is 0.6 newtons. The other end of the string is fixed to a point A on a rough horizontal table, so we are going to have friction. Coefficient of friction between P and the table is 1/7, so mu is 1/7. Particle P is projected from A with this speed. So let's going to do quickly a sketch to see what we have. So we have a horizontal table, we have a point A, we have a string, and we have a particle P here, well, touching the surface. We have some friction. At the beginning, it says particle P is projected from A. So at the beginning, my particle is here with the speed 1.8 along the surface of the table. After traveling 0.8 from A, the particle passed through point B. So let's say this is B. This is 0.8, which is the natural length of the string. So up to here, so at the beginning, I don't know if you can picture that, but at the beginning, if this is A, I have something like this. It's just a string that is not taut. It's just completely slack. And so this is at the beginning. I don't have any influence of the string at all. And here at B, when this is 0.8, suddenly the string gets taut. So this is what is happening so far. Velocity at A is 1.8. They ask, first thing, find the speed of P at the instant it passed through B. So they are asking us the velocity here. There are like two ways of doing, at least. One is so bad because this bit I don't have any elastic energy, so that means that the acceleration is going to be constant. And the other way is with work energy principle. So I'm going to use so bad because I think it's just simpler, but it's really up to you. So in this particle, before it gets taut, I have only friction in this way. The friction. So my equation is going to look force is mass acceleration because I want to find the acceleration. Force is just the friction. Negative is going to be the mass, which was 0.4 kilograms, 0.4 A. But I can find the friction because it's moving, so it's going to be maximum. And you know it's going to be mu normal reaction. So that friction is going to be mu is 1/7, and the normal reaction is going to be, this is the weight, and the normal reaction is here, is going to be the same as the weight, so time by 0.4 times by G. This is 0.56 Newton, and this is your first mark for finding the friction. When you have the friction, you can find the acceleration. So 0.56, 0.4 acceleration, and that way the acceleration is going to be minus 1.4, which is deceleration because I have friction here and I don't have any force towards the other direction. So if I apply subat now to that bit, I can write subat. Displacement from A to B is 0.8. Initial velocity is 1.8. Final velocity is what they ask, and acceleration is minus 1.4. And I don't need the time. So I'm going to use one subat equation without time, which is this one. V squared is U squared plus 2AS. I substitute everything that I know. So V squared is what I need to find. U squared is 1.8 squared minus, because acceleration is negative, so I'm going to write at the front, 0.8. And from here, you get two values of V. One is negative, we are not interested, and the other one is the positive one, which is 1 meter per second. So this is the velocity, that's what they ask. And these bits are 3 marks for method and 1 mark for the answer. 1 mark would be for finding the acceleration, 1 mark for applying the Subat equations, and 1 mark for forming that this equation correctly. So I think 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So your 5 marks. The other way is using work energy principle. It's up to you, really. Then the particle P, so for B, the particle P comes to rest at point C on the table where A, B, C are in a straight line. So we have now our particle somewhere here, a bit farther away. This is point C. This is the table. And it comes to rest. Find the total distance traveled by P as it moves directly from A to C. So we know from here to here has moved with constant acceleration and has moved for 0.8 meters. And now we need to find this second bit, BC. We know the velocity here is 0. Velocity is 0. But be careful, because now when I have an elastic thing, the acceleration is not going to be constant anymore. So never ever use Subat equations when you have elastic things acting. So we can use the work energy principle. So I'm going to do in the next page. So, and I would specify, so work energy principle. That means that the work done against friction is going to be the change in energy. So the work done against energy, the work done against friction is the friction times the distance. And the distance is the distance BC, and I'm going to call it, let's say X, for example, right? This is X. So the work done will be friction times by X, and this is going to be energy at B minus energy at C. Energy at B, because I'm going from B to C, energy at B, I have not potential energy, or I don't have change of potential energy because they are not moving up or down. I have only kinetic energy because it has a velocity, this one that I found. The string is still not in action, if you want to think that way, so it's just taut, but it's not stretched. So I don't have any elastic energy. So my energy there is going to be just the kinetic energy. So 1/2 of the mass velocity squared. Then minus energy at C. Here, velocity is 0. So I don't have kinetic energy, but I have all the elastic energy, potential elastic energy from the string. And that energy, remember, is going to be lambda x squared divided by 2L. Remember, this formula is not in the formula booklet. You have to remember it. So if I substitute what I know, the friction is going to be 0.57. We found it before. X is going to be 1/2 of the mass, that was 0.4. The velocity is 1. We found it at B. Squared minus lambda was 0.6. 0.6 x squared, and then divided by 2 times 0.88. This is just one quadratic with x. So if you just reorganize the equation, you have something like 0.375 x squared minus 0.56x minus 0.2 equals 0. And then x is going to be 0.2977. The other value is negative, so we don't want that. And they are asking us, so this is the distance that has a stretch from B to C. The elastic string has a stretch, but they are asking us total distance traveled by P from A to C. So we have to add this 0.8 that it moved at the beginning. So the total distance, we can say, is the 0.8 is the L plus, so the natural length of the cable, of the string, plus this 0.977. So it's more or less 1.1 meter. Yeah, so you have 3 marks for the method. So 1 for using the work energy principle, 1 for write correctly the equation and for substituting everything correctly. 1 for this equation, 1 for this value of x, and 1 value for adding the 0.8. So it's 1, 2, 3, 4, 5, 6 marks, right? Yeah, 6 marks. And then show that P remains at rest at C. So we are here now, and the forces that we have acting is the tension of the string, and as it has a stop and is going to turn back the way, the friction is in the other direction. So at C, in this situation now, so when the particle is at C, the forces that I have acting are the tension of the string, just pulling it back, but they have friction in the other direction because it's not moving, but you know the friction goes against the tendency of motion. So it won't move if this tension is smaller than the friction. So if it's not enough to overcome the friction. So this is what we are going to check. What is the value of the tension? And we are going to compare with the value of the friction that hasn't changed because nothing has changed. So the tension of the elastic spring is lambda x divided by L. So it's going to be our 0.6 times 0.2997 is how much the cable is stretched, the string, and divided by the natural length. So this tension here is 0.225, which is smaller than our friction. Yeah, so tension is smaller than friction, therefore it won't move. It won't move. It's not enough to overcome the friction. Again, you have 3 marks here, or 2 marks, no, 3. You have 1 for using this method, 1 for finding the tension, and 1 for your conclusion. Even if it was already given, they are asking you to prove that it won't move, you have to show it. Yeah. This is all for this question. Hello, if you like the video, I have a free last-minute revision course the week before your exams. The link is in the description below. I'm working with international levels for Edexcel, but if you are an UK student, you will find this very helpful as well because the questions are identical, you just have less topics. I have other courses through the year, they are all in my website and the link is as well in the description below. I would love to help you.